Hi, everyone, and welcome back to Vector Lab. Today, we're going to show how to build a supply chain copilot with the OpenAI Agent SDK and Databricks MCP servers.
Amazing. So what is the use case about?
Yes, this demo focuses on how you can do, you can have like your supply chain, enterprise data, then you can do some cool analytics on top. And what we're going to show is how to then expose everything through Databricks managed MCP servers and have it orchestrated by OpenAI Agent SDK. So that's the TLDR.
And then the kind of a front end or user app is on the ChatGPT side.
It's going to be exposed via a React app that I'm going to show in a second. So this is going to look like this, the output, just a copilot like that you can interact with through this React app, where you can ask questions such as what products are dependent on this particular material, how much revenue is at risk, if I don't have the forecasted amount of product that I need, what products have delays right now. Lots of different questions are going to leverage different parts of, like your analytical workloads that you have. And this is something that based off a cookbook that I recently published early July that explains end-to-end how to do it.
Okay, so then we'll have some structured data, unstructured data, serve them through MCP on Databricks side, and then connect everything on the OpenAI side.
Exactly. Well, maybe you can just go directly to the architecture. It's exactly like you said. So if you look at the architecture, you're going to have your enterprise data. So typically your inventory, sales, supply feeds, local events, etc. Then you can build some analytics on top, and it can be really anything. You can have queries against your structured inventory data, demand supplier data, maybe SQL queries. You could do some forecasting, on top with time series forecasting. You could also, we're going to show how to do like graph processing on top so that you can map, material requirements, how you can optimize transport, etc. You could also have unstructured data like emails that you need to store in a vector index. And as you said, you're going to first expose those as functions in Databricks Unity Catalog, which is a Databricks governance module. And then those can be exposed via MCP servers, and Databricks provides managed MCP servers for UC functions or even for vector index.
Excellent.
And then we're going to show how you can have the OpenAI Agent SDK orchestrate everything so that it can, depending on the question that it receives, leverage the tools that it needs in order to query the insights that it needs to give a response that is going to be shown in the front end. So that's the architecture in the nutshell.
Nice. So do we deep dive?
Yes, let's do it. So first thing first, you need to set up your Databricks authentication. So I'm not going to go too much into details here, but you just add a profile to your Databricks config file. And then for that, you need a PAT, a personal access token. And I've listed in the cookbook how to get it via settings, developer, etc. in the Databricks environment. And then, of course, you can choose to use your own supply chain data. You don't have to use this. So if you prefer to use your own data set and models, totally fine to just go straight to the part, where we're going to build the agent and the MCP connection. But just in case you do that, make sure to wrap all the relevant components as Unity Catalog functions, define a vector index if you have unstructured data, etc. You could also even expose Genie spaces. I haven't done it here, but that's totally doable.
Yeah, Genie space is also kind of a managed MCP.
Yes, the latest I checked, you can have 3 types of Databricks managed MCP servers: functions, vector index, and Genie spaces.
Yes,
and Genie spaces are great for text to SQL. Yeah. So some of you might be familiar with it because we had a similar demo in another video, but here we take the scenario of a pharma network where we have plants, 3 plants that manufacture a certain amount of products, ship them to distribution centers, and then each distribution center will serve wholesalers. And here we're going to do a bunch of analytics on top. And so for that, you can just clone the repo that is indicated here, and you're going to be able to set up everything by just running notebook 1. I'm not going to go through it, but you just need to run everything, define the catalog that you want. The only thing that you need to set up is set up your OpenAI API secrets, and we recommend that you use Databricks secrets for this. I'm not going to go in details, but the cookbook explains step by step how to do it.
Nice. Okay, that builds the kind of authentication layer.
Exactly. Well, this is going to do the authentication, but then either you run all the notebooks that are going to do all your workloads at
Okay.
once by running just, you have those magic commands in notebook 1 that's going to run dynamically, like this notebook 2 that you see here, and then notebook 3, etc. So you could just run notebook 1, and what you're going to end up with is in your catalog, like Unity catalog, you're going to end up with a bunch of tables, bunch of functions, etc., that we're going to use.
Okay, sounds good.
And just going very quickly through like what we're setting up here in terms of analytical workload. This notebook 2 is all about generating a 1 week ahead forecasting for every wholesaler and distribution center with the whole winter seasonal model, but you could use obviously any preferred time series approach. One thing that's noteworthy here is that we're leveraging Spark's parallelization for large scale forecasting by using Pandas UDF, where you take your single node data science code and you distribute it across multiple nodes. I think people who've been using Spark will probably know about it.
This is more for training models in parallel, right? So here you are training a model per distribution center. And
Yeah,
so instead of doing this sequentially one by one, you just repartition and split it in different nodes and you do parallel model training of different models though.
exactly. And
Nice.
then those forecasts are rolled up to distribution center level for each product. And what you get that we're going to leverage as insights is a product demand forecasted table that give you the aggregate forecasts at the distribution center level. So like your forecasting.
So it's like distribution level products and what is the forecast?
Yeah, I think that was so at distribution level, if I go back here, so here, that
Okay,
gives you the forecast.
sounds good.
Then notebook number 3 is all about building, like using graph processing to get a product to material mapping. So you basically take the bill of materials and you calculate the component requirements at scale. So you transform here the bill of materials into a graph so that a product forecast can be translated into precise raw material requirements. And so the output, I'm just going to skip to the end because really you could use any type of analytics that you want. But what we wanted to have here is to have raw material demand and raw material supply. And here you could use any other logic that you want because everything is going to be wrapped in a function that is then leveraged by the agent. And so that's the key thing to remember. Then notebook 4, it's all about optimizing transport. So we just want to minimize the plant to distribution center transportation cost under some constraints like capacity, demand, etc. And so for this, we leverage Pandas UDFs again, and we're going to output recommendations down there. I think this is in a table called, shipment recommendations.
Okay, cool.
And
So we
then,
have forecasts, we have graph. Actually, we don't care about the graph, but raw materials
yeah,
to demand to raw materials to supply of materials.
and vice versa.
Yeah. And then the recommendations.
Yeah, and then the transportation optimization. And then this is just one notebook that shows, for example, if you have emails from like supply chain managers saying, hey, there's a delay, etc., this unstructured data, this shows how you can put it in a vector index. And then here we're using a OpenAI text embedding 3 large to embed like those emails, put them in a vector index in Databricks. And then that allows you to do semantic queries that surface delays, risks, etc., about your supply chain. And then I think we already discussed that quite a bit in previous videos, but it's all about creating Unity Catalog functions that are going to leverage this logic and expose that as functions that can be leveraged by agents. So, for example, you can have a product from a row function, row from product function. You can have a revenue risk function, a lookup product demand function, a query unstructured emails function, etc. So everything is saved as functions in those two notebooks in 5 and 7.
So then these functions mainly are being used to expose this data to as tools to the agent. And so
Yes.
the agent now can fetch these tools to go and make like answers based on real business data.
Yeah, and the agent can decide at runtime, what should I use as tools? Like, should I use the forecast tool? Should I do a bump dependency? Should I look at the history? Should I search emails? Which is why it's good to have like then an orchestrator, a bunch of tools that are exposed in this case by MCP.
Nice. And then one key point on the tools is the metadata, the description of the tools need to be crystal clear, because
Yes.
based on that, the orchestrator needs to understand which tool I need to fetch to answer this question.
That's an excellent point. You need to provide information. The more precise you are, the more precise your agent is going to be at leveraging the right tool for the right task. Yeah. Okay, so now let's assume, so we've run everything and we have everything we need like we've shown here. So you have all those nice tables, you have all those nice functions ready. And so now let's go to the new thing that we want to talk about today, which is connecting to Databricks managed MCP servers. One thing that's good to mention is that currently the MCP spec defines 3 kinds of servers based on the transport mechanism they use. And Databricks hosted MCP endpoints. They sit behind like the most recent one, the streamable HTTP transport that's defined in this spec. So use this. Also, one thing to note is that you need to make sure that your workspace is enabled for serverless so that you can connect to the Databricks managed MCP.
Yes, mainly you need UC and serverless enabled.
Exactly. And so once we have that, now we're going to show how to serve this agent with FastAPI and chat through a React UI. So now we're going to show how to integrate those Databricks MCP servers into an OpenAI agent. And so here you can just click to get to the GitHub where you can get all the files, but we're going to start with this main.py file. This is where the whole agent logic sits, and it's going to use the OpenAI agent SDK and expose Databricks MCP vector search endpoints and Unity Catalog functions in here as callable tools. It starts by reading some environment variables here. So this is where you can, define your target catalog, schema, UC function path. And then we're going to have our 2 tools. So the vector search tool, which queries a Databricks vector search index, and then the UC function tools, which executes Unity Catalog functions via MCP. And so when you call these tools, this is going to return a raw JSON from the Databricks REST API.
Just one thing to mention here, since you showed the fetching from like defining the catalogs and etc. There were a lot of questions around if we can, in the same app, if we can bring MCP servers that sit in different catalogs. And obviously, the answer is yes. You can define exactly which catalog you want to fetch which MCP server. So for reusability of MCP servers mainly.
That's a very good point. That's really good to know. So then inside the agent, we're going to instantiate an agent that we call here assistant, for lack of a better word. And we want it to be hard-coded, hard-scoped to supply chain topics. And then every response needs to invoke one of the 2 registered tools. And we have guardrails actually that I'm going to show you later that force the agent to refuse anything outside logistics, inventory, procurement, or forecasting. Yes. And then each user prompt is processed inside an SDK trace context. So this is where the agent is defined. Then we have like Databricks.
Can you explain a little bit the SDK trace context, is it very similar to MLflow tracing?
Yeah, I would say so. So if we go here, this is where I have my traces.
Mm-hmm.
And so for every query that you have a detailed trace of what happened, etc. So I would say quite similar from that point of view. Now, just very quickly, Databricks MCP is just, the goal of this file is just to obtain the path that we created earlier from a given workspace client. And so that means you can just define all of your Databricks OAuth logic there and not have it in your main.py. And then one last thing, this is where I define the guardrails. To be honest, it's just a really lightweight output guardrail. And the way that you work with guardrails in the agent SDK is that you spin an agent. So here, I can't remember how I called it, supply chain check. It's going to classify candidate answers. Then the main agent will hand, every time it drafts a reply, it's going to hand it to this checker, and this checker is going to return a pydantic object with a Boolean is supply chain. And so if that flag is false, the guardrail is going to raise a tripwire and the caller swaps in a refusal. So very, very basic. So now we can serve the agent with FastAPI. So it is as easy as, I think I have the code here, as copy pasting this. So here, that means the API is going to be available. And so at this, I think, localhost, port 8000. And so that's just a FastAPI backend that exposes your agent as an endpoint. And so here, very quickly, first we have the config so that the local front end can talk to it. Then we just define build MCP servers. That's going to authenticate to the caller's Databricks workspace. It's going to construct server tools. So one for the vector search, one for Unity catalog functions. And then what you have is that each incoming post to chat will contain a user message. And that's where, again, the model is forced to call a tool for every time that, a message is written by the user. And that's how it works in the back end. So that's how to do it. And then we're just going to do a second one, which is I completely vibe coded this front end, by the way. I have zero skills in front end. And I find it amazing how easy it's becoming for us to be able to spin out, apps nowadays. And so, you just need to cd into UI, and then the app is going to be available at the defined host. And so it's just a user-friendly interface for interacting with the backend agent. It has components for displaying the conversation history, text input for sending messages. But again, I very much vibe coded on this one. It's a very basic app, so I'm sure we could make it much, much better. If anyone has any tips on how to make it better, please send them. And so here you can just start typing your questions. And then in the background, the agent is going to leverage the right tool in order to answer the question. And you're going to have the answer displayed here. And when you call it, you can always see the trace appearing in your dashboard. Sometimes it takes a bit of time to answer, depending on how complex the question is and how many tools it needs to call.
Nice. And all the tool calling and tracing is happening on the backend that you showed.
Yeah.
And Lara, I have this question. So instead of spinning up this app, is there any way to just add these MCP servers on the ChatGPT UI? And so your app is your...
connects. 100%.
Right.
Yes.
I have this vision that apps will go away and everything will be through these conversational interfaces as another tool.
100%. Yeah, that's something that's already being done. You can 100% take your ChatGPT app and connect it via MCP to Databricks to answer questions. Yeah, 100%.
Interesting.
Yeah, I agree too. It was the first time that I,
Oh yes, I was
managed to vibe code build an app. So I was very happy about it.
Yes, no, I was just curious if that is now possible.
It is possible, yes, which is very cool.
Mm.
But yeah, if anybody has any tips on how to improve this, I don't think it's currently multi-turn, so I could probably work on making it multi-turn. We could also add Genie Space
Yeah.
MCP servers. I just didn't do it here, but that's also something that can totally be done.
The good thing here is now the data sits in Unity catalog. And so with your path token that is for your user, I guess, this is how you build it, right? All the authentication layers to the UC level permissions are propagated, right? So theoretically, if you were not allowed to see part of the table, you will only be able to see what you are allowed to do based on the UC permissions you have on that table. The level of
That's a very
permissions.
good point for
Yeah.
people who are not familiar with UC functions. So Unity Catalog is the Databricks governance model. And when you define those functions, you define permissions, who can see them, what they can see, etc. And so I can only query what I have, access to,
Nice.
which is
I took for granted people know about UC. Yeah, sounds good.
great.
Thank you, Lara.
Thanks.